Now, if we wanted to look at this on the calculator, we have the calculator display, and we go into the main menu, 2 for statistics, and distribution, normal distribution, and here we want to go for cumulative distribution because we're adding up the probabilities from 0 centimeters to 35 centimeters long. Just like we saw on the curve here, we're adding up all this area here up to 35 centimeters. We want to find the probability that a given trout is within this size range. So we set up a cumulative normal distribution. Our lower bound needs to be not 0, but a very negative number. So this is -1 to the power of -1 multiplied with 10 to the power of 99. The upper boundary is 35, and the standard deviation is 6.1, and the mean is 39 centimeters. And we execute, and we find, the probability is 25.6. So that's just the same as we found before. Now I'll just write up question B. The question is, Cliff catches 5 trout in an afternoon. Find the probability that at least 2 of the trout are more than 35 centimeters long. State any assumptions you make. And the assumption here is that these trout are independent of each other, that their lengths do not affect the lengths of the others, or the probabilities don't affect each other. Now, is this, would it be appropriate to use the normal distribution model here? Well, what do we have? We have that Cliff catches 5 trout, and we're asked to find the probability that at least 2 of the trout are more than 35 centimeters long. Now this seems to be, it seems to have something to do with binomial distribution, because we have a number of trials here. We have 5 catches, so he catches 5 trout, so that gives us 5 trials. And the other parameter for binomial distribution, that was the probability in each trial. And we've found this probability in each trial. It's 25.6%. So we can set up this second experiment as, okay, we'll call this random variable C, which is binomially distributed. And the parameters are 5, because we have 5 trials, 5 trout catches, and the probability for each trial is 0.256.